The natural instinct for building combs. Honeybees instinctively build hexagonal combs due to the efficiency of the shape. When bees create honeycomb structures, they use their mandibles to form wax, which they then mold into individual cells. These cells are arranged in a hexagonal pattern because it is the most efficient geometric shape for packing the maximum amount of honey in a confined space while using the least amount of wax. The role of the bees' mandibles in wax production. Honeybees produce wax from specialized glands on their abdomen. They chew the wax until it becomes soft and pliable, then use their mandibles to shape it into cells. The bees' ability to secrete wax and manipulate it with precision allows them to create the interlocking hexagonal cells, each of which is perfectly suited to storing honey, pollen, and housing their larvae. Efficiency of the hexagonal shape. The hexagonal shape of the cells offers optimal storage capacity. It is a perfect balance between strength and minimal use of material. Compared to other shapes, hexagons fit together without gaps and require less wax to build, making it the most energy-efficient option for honeybees. This allows the bees to store more honey while conserving the wax they produce. The role of temperature and the bees' movements. As the bees build the comb, they use body heat to soften the wax and encourage it to become pliable. Their collective body heat, combined with synchronized movements, helps in molding the wax into a uniform shape. The bees instinctively work in harmony, with each one focusing on different sections of the comb, ensuring that the cells are uniformly sized and aligned. Mathematical precision in nature. Scientists have long been fascinated by the mathematical precision of honeybee combs. The hexagonal arrangement ensures that there is no wasted space, as circles are the only other shape that would fill a given area. However, creating circular cells would require more wax and reduce the efficiency of the structure. Bees naturally solve this mathematical puzzle, forming perfect hexagons through instinctive behavior. Cooperation in colony construction. The construction of honeycomb is a highly cooperative activity. Worker bees work together to build the combs, with each bee focusing on a specific task, whether it's producing wax, forming cells, or packing pollen. This teamwork ensures that the hive's comb is constructed quickly and efficiently, maximizing the colony's storage space for honey and larvae. Wax heating and cell formation. As bees continue to build the comb, they regulate the temperature of the hive by fanning their wings, keeping the environment at an optimal level for wax production. Once the wax is softened, the bees use it to form the foundation of each cell. The initial cell construction is often irregular, but bees quickly refine the shape, smoothing it into perfect hexagons. The intricate geometry behind comb construction. The process of creating hexagonal cells begins with bees forming circular foundations. However, when bees form these circles side by side, the natural pressure between adjacent circles leads to a shift in the shape from round to hexagonal. This transformation is an example of natural geometry at work, where the bee's behavior forces the circles to adjust into the most efficient and stable form. Bees' instinct for perfection. Despite being small creatures with limited cognitive abilities, honeybees are capable of constructing intricate and highly effective structures. Their instinctive behavior leads them to form perfect hexagonal cells without needing any formal training. This remarkable ability is a result of evolutionary pressures, where the most efficient honeycomb designs have been naturally selected over time. Hexagonal honeycombs an evolutionary advantage. The hexagonal comb design provides honeybees with a clear evolutionary advantage. The strength and efficiency of the structure allow bees to store large quantities of honey and pollen while using minimal resources. This energy-efficient design helps the colony thrive, providing ample food supplies for the winter months and space to raise their young.